Okay, so today is about advanced application problems. Problems that are a little more advanced. But we're going to start with the simple stuff. 5 to the negative 2. 5 to the negative 2 is just like 5 to the 2, 5 squared, which is 25, except that negative thing doesn't make it negative 25. It makes it what? 1 over 25. Okay. 49 to the 1/2. There's a way you're used to saying that with two words. Square root. Yes, it's the square root of 49, which is 7. Why isn't the answer 7? It says they added a negative in there, so is it negative 7? It's 1 over 7. Okay, this one, it's just ignore the negative for a second. Let's do the 2. 3/4 squared. What's that? 9/16, just like you'd kind of expect. So it's 9/16, but then what does that negative do? Flips it. What? So it is what? 16/9. Next one, 27 to the 4/3. That's like 27 to the what? To the what? 1/3 and then 4. Always make it smaller and then make it bigger. What's 27 to the 1/3? 3. 3 to the 4th? 3 to the 4th means, and the easy way to do this is 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Okay, so either way, though, 3 to the 4th is 81. 8 to the negative 2/3. Would you please, on your paper, show me how you can break that into 3 parts? 8 to the this, to the this, to the this. I'll pause while you do that. 8 to the 1/3. Then to the second. And then to the negative 1. Very good. Okay, 8 to the 1/3 is what? 2 to the second is? And then the negative 1 thing does? 1/4. All right. Next, we have this one, and the common mistake involves doing this. First, they add 7 to both sides. Is that okay or not? Yes. Then, they divide by 2 on both sides. Is that okay or not? No, it's not. Why isn't it okay to divide by 2? Yes? Yep. First you add 7, and then you'll have 2x in parentheses to the 1/3 equals 3. Then you got to get rid of this 1/3 first before you get rid of the 2. Okay, it's hard to explain why to people other than it's the order of operations. And if we were doing this problem, we would do the power first. When we're undoing it, we're going to undo that power first. I don't know if that's the best way to say it, but bottom line is we need to get this to the 3rd. So that's 3 to the 3rd. Is that 9? No, what is 3 to the 3rd? 27. So then the last step would be to do what? Divide by 2. Is this problem going to be done the same way? Why not? Why not the same way? No parentheses. All right, try that one, please. It does no parentheses. It just means you do it in slightly different order. I'll pause while you work on that. So, Mr. T, tell me how to start. Subtract 5, and I've got 3x to the 3/4 equals 24. Now what? How come last time we didn't divide by 3? We did the power first. Last time it was in parentheses. Now it's not. Very good. Okay, so then it's x to the 3/4 equals 8. And this is different than if we were going to do the 3/4 power, because we're going to have to undo that with what? 4/3 power. 4/3. Now we got to do 8 to the 4/3. So let's break that up. To the, and what is 8 to the 1/3? And what is 2 to the 4th? Raise your hand if you guys had 16 for an answer, and that's almost everybody. Good job. Okay. Here is the new stuff. It's advanced applications. So they generally work in a formula. There's generally a formula for that. Now, last time, they gave you the formula and said stick numbers in. This time, they're going to give you only a real-world situation. You have to know the formula ahead of time and then know where to put the numbers. Okay, so copy this one down, except I would, above this formula here, I'm going to write the simple way to remember this. This is the starting number, what you start with. This is the ending number, what you end with. R is the rate, and N is the time. The time could be in years, it usually is, or it could be months, or it could be whatever. All right, so we're going to use a real-world situation to demo this. I went to St. Olaf College, graduated in 1990. I am not positive of this. It'd be awesome if somebody could look it up, but I'm going to be close anyway. It was around 11,500 by the time I graduated from St. Olaf. So the starting tuition was about 11,500. So I would just put that right there. So I'm going to start creating an equation, and starting is 11,500. And then I have this 1 plus the rate. I don't know what rate it went up at. I know it was like 6-7%, something like that. And I do know how many years it's been. It's been 20 years since I went there. And now the end would be what? What would the end number be in this real world situation? What? How much it is now, exactly. After 20 years, how much is it now? And it's 47,000. So the question is, what rate did it go up at? Well, there's the equation. I just stuck in all my numbers. I want you to try to solve it right now. I'll give you a hint. Some kids do this wrong because they subtract 11,500. What should they do? Goodbye. Okay, start with that. Started with the 11,500, dividing by that, and then you got some decimal here. It's like 4 point something, wasn't it? 4.1? Should be about 4 point something, like 4.1. And then we put everything to the 1/20th power, which came out to 1 point something, 1.067. 07, wait a minute, I'm making different numbers here. 0.072. All right. And that equals 1 plus R. And then you subtract 1 from both sides, you get 0.072 is R. That looks like a rate to me. 0.072 means about what percent? About 7%. 7.2% to be exact. All right, so that means since I was there, if I have my numbers right, that it's about 7.2% increase per year between now and then. Yes? It's a good point. Question is whether or not we'd use plus or minus in this situation. The question was whether or not we'd have to do plus or minus. And since this is a real-world problem, negative 0.7 or 7.2% wouldn't make any sense. But the point is good, though, because when we were solving this, and we at the point where we did this to the 1/20th power to solve it, we were kind of like doing a square root, except we were doing a 20th root, and that is an even number, and therefore yes. And therefore, yes, it should have a plus and a minus, but in the real world, you only care about the ones that work in the real world. So that's why. So that's a good point. All right. Look at this one. I'd like you to read it. I'll pause while you do. Here we go. This is the starting amount, 5,000 bucks. 1 plus R to the, how many years did you figure that out? 49. Very good. And then it was now ending value 48,000. And if I divide by 5,000 on both sides, you end up with what here? 9.6 equals 1 plus R to the 49th. And in this case, we're doing it to the power of 1 over 49, which is not an even root, and therefore we don't have to worry about that plus minus thing. But final answer when you're done, R equals about what percent? 4 point what percent? 4.7-ish? All right. Remember when you were doing this to the 1/49th, that and the calculator would need to go in a parenthesis. That might mess somebody up. All right. So there's a typical problem for today. You got a starting number, you got an ending number, you can figure out the rate. One other thought, though, is if you ever are in a situation where they tell you the rate but they don't tell you the years, you'll end up with something like this. And the only way you can do that is if you can make the bases the same, which we can't, or if you use logs, and that's what we're learning next.